All right, this will be the first part of section 3, which is real zeros of polynomial functions. We're going to find better ways to find all of our zeros. So let's think about this graph. We don't know exactly what it does, but by looking at the graph, we can see that there's a 0 at x equals 2. If I graph it, I can see there's one right there. Here, I don't know what's happening, but we know x minus 2 is a factor. Since x equals 2 is a 0, x minus 2 must be a factor. That means there must be a second degree equation or polynomial, q of x, meaning it has a squared in it, right? Because squared times an x makes that x cubed we started with, such that our f of x could be broken into x minus 2 times whatever that is. But the question is how we find that. We use long division, and then we can use that answer to factor further. For long division, we set it up just like long division with numbers. I'm dividing by x minus 2, so it goes out front. My division symbol, I'm dividing into this, so it goes inside my division. And there we go. Now we do polynomial long division. I start by saying, okay, x times what makes 6x cubed? Well, x times 6x squared makes 6x cubed. Then I multiply 6x squared times my whole divisor. Makes 6x cubed minus 12x squared. Then we subtract. We're subtracting the whole thing, so I always put parentheses around it because I like to say, all right, make that plus and change the signs. 6x cubed and negative 6x cubed make a 0. Good. Negative 19x squared and positive 12x squared makes negative 7x squared. Then, just like with regular long division, we bring down the next number. And now I ask myself again, okay, x times what makes this number now? X times what makes negative 7x squared? Well, that's negative 7x. Now I'm multiplying negative 7x by the whole divisor. Makes negative 7x squared plus 14x. Now again, I will subtract. Whole thing in parentheses there. And this is why I like to change my signs to plus the opposite. Negative 7x squared plus 7x squared is 0. 16x plus negative 14x is 2x. And then I bring down the last piece. I have 2x minus 4. All right, x times what makes 2x? That's positive 2. Make sure you put the plus with it. And 2 times that divisor makes 2x minus 4. When I subtract, notice that I change my signs. I get 0 and 0, a remainder of 0. Good. If it's a factor, I want a remainder of 0. So that means to factor f of x, it is our starting polynomial, which was x minus 2, times 6x squared minus 7x plus 2. What we got is our answer. Now we might be able to factor that. That's what we try to do. All right, 6x squared. I would usually go with 3x and 2x. To get a minus 7 in the middle, I think I want 2 and 1, minus, minus. So I'm using minus 4x, minus 3x, makes that minus 7x. Here is our fully factored version that we didn't know before. So that gives us the division algorithm. Assuming the degree of d of x is less than or equal to the degree of f of x, and d of x is not 0. So basically, I'm taking f of x divided by d of x. All right? D of x has to have a smaller degree. We have some vocab. F of x is going to be our dividend. It is what we are dividing into. D of x is our divisor. It's what we're dividing by. Q of x here is our quotient. And R of x will be our remainder. The division algorithm says I can take a function, rewrite it as two things multiplied together plus a remainder. What I divided by times what I got plus the remainder. We can also write it in fraction form. So this is still the same thing. R of x is still my remainder. Q of x is still my quotient. D of x is still my divisor. And I didn't label it, but f of x is still our dividend. So I can say a function divided by another is equal to the quotient plus the remainder over divisor. These are both acceptable ways to write it, but different times it will call for different forms. And a note on the division algorithm. Before we apply the division algorithm, we want to do two things. We want to write the dividend and the divisor in descending powers of the variable. It makes your life way easier. Do it. And insert placeholders with 0 coefficients for missing powers of the variable. So what that means is if I have an equation like 3x cubed plus 4, before I start dividing, I want to rewrite this. Notice I'm missing an x squared, so I want 0x squared. I'm missing an x, so I want 0x, and then my 4. I want to have every power in my divisor and dividend before I start the division. So let's try one. We're going to divide x cubed minus 1 by x minus 1. So I put my x minus 1 out front, dividing into x cubed. Remember to put our zeros in though. 0x squared plus 0x, and then my minus 1. All right, we look at x times what makes x cubed? X squared. Take that x squared, multiply it by the whole divisor. I have x cubed minus x squared. Then we subtract that whole thing. I like to change the signs, make it plus the opposite. That gives me a 0 plus x squared. Bring down my next term, 0x. Now I again ask myself, x times what makes x squared? Well, it's x. Since it's positive, we need a plus. X times x minus 1 makes x squared minus x. And then again, we subtract. I like to distribute my minus. There we go. I get a 0 plus x. Bring down my last term. X times what makes x? Well, that's a positive 1. 1 times x minus 1 is x minus 1. And now when I subtract, change my signs, I get a remainder of 0. So that means x cubed minus 1 divided by x minus 1 is equal to x squared plus x plus 1. So x cubed minus 1 divided by x minus 1 is equal to x squared plus x plus 1. This also means that I could rewrite x cubed minus 1 as x minus 1, what I divided by, times my quotient, plus the remainder, but there was no remainder. All right, dividing this one. All right, first step, rewrite it in order. My divisor, rewrite it in order, x squared plus 2x minus 3. My dividend, I start with 2x to the 4th power, then 4x cubed, then minus 5x squared plus 3x minus 2. You want them in order, otherwise it makes your life way harder than it needs to be. All right, now I take my first term, x squared, that's the one I'm worrying about. X squared times what makes 2x to the 4th power? That is 2x squared. Take that 2x squared, multiply it by the whole divisor. 2x to the 4th power plus 4x cubed minus 6x squared. Then I subtract. And now is when I find it really helpful to distribute the minus. Because I get a 0, I get another 0, and I get a positive x squared. Bring down my next term. And here's another little trick. If there's 3 terms in the divisor, you need 3 terms to be working with here. So we have to actually bring down 2 terms. Now x squared times what makes x squared? 1. It doesn't really matter where you put that 1. Usually I line it up, but over there is fine too. I have x squared plus 2x minus 3. And now I subtract. Distribute that. I get positive x plus 1. So my answer here, remember I can write it two ways. I can say that 2x to the 4th power plus 4x cubed minus 5x squared plus 3x minus 2 divided by x squared plus 2x minus 3 is equal to 2x squared plus 1 plus my remainder, which is x plus 1, over what I divided by, x squared plus 2x minus 3. Notice I knew I was done because x squared can't multiply into x. As soon as the degree is smaller, I can't do it anymore. I can also write this as my original function equals what I divided by, my x squared plus 2x minus 3, times my quotient, 2x squared plus 1, plus the remainder of x plus 1. Basically says I could multiply those out, but then I got a little more I got to add on. All right, another example. Very similar to the last one. These are already in order, so let's dive right in. X squared minus 3x plus 5 going into 3x to the 4th power minus 5x cubed. Uh-oh, I don't have an x squared term. Don't forget to put the 0x squared, then plus 4x minus 6. It'll throw your life off later if you don't put it in. So x squared times what makes 3x to the 4th power? 3x squared. Multiply that through, I get 3x to the 4th power minus 9x cubed plus 15x squared. I will subtract. And let's distribute that because it makes my life easier. I have a 0. I have positive 4x cubed minus 15x squared. I have 3 terms in my divisor, so I need 3 terms to be working with over here. So I'll add the 4x now. X squared times what makes 4x cubed? Positive 4x. Distribute that 4x through. I get 4x cubed minus 12x squared plus 20x. Subtract as always. Distributing, I have a 0. I have negative 3x squared minus 16x, and bring down my minus 6. And then x squared times negative 3 makes that negative 3x squared. Distribute my negative 3 through. I get plus 9x minus 15. And subtract to get my final remainder. I know it's the final remainder because I'm going to have 0x squareds, and I'm dividing by an x squared, so I can't do anything else. So I get negative 25x plus 9. All right, my final answer then. I can write this as f of x now because it called it f of x, divided by x squared minus 3x plus 5 is equal to 3x squared plus 4x minus 3 plus negative 25x plus 9 over, my divisor was x squared minus 3x plus 5. That's the way we'll write it a lot. Otherwise, remember, we can write f of x equals my divisor times my quotient plus my remainder. Either way, totally fine. And another example, same thing as before. Put my divisor out front. X cubed plus 5x squared minus 7x plus 2. All right. X times x squared makes my x cubed. Distribute that, I get x cubed minus 2x squared. Subtract. Change Change that to plus the opposite. I get a 0 and a 7x squared. Bring down my minus 7x. Well, x times 7x makes 7x squared minus 14x. And then I subtract. Changing the signs, I get a 0 and I get a positive 7x. And bring down my last term. X times 7, so 7x minus 14. And when I subtract those, I get 16. The final remainder is 16. So that means f of x divided by x minus 2 is equal to my quotient, x squared plus 7x plus 7, plus 16 over x minus 2. I could also say f of x is equal to my divisor times my quotient plus the remainder. All right, got another one for us. Divisor out front. Going into my dividend, 2x to the 4th plus x cubed. Don't forget that 0x squared plus x minus 1. All right. X squared times what? 2x squared. Distribute that 2x squared, we get 2x to the 4th plus 4x cubed minus 2x squared. When I subtract and distribute that subtraction, we get a 0. We get negative 3x cubed plus 2x squared. Bring down the next term. All right, so that's going to need a negative 3x here. Distribute that, I get negative 3x cubed minus 6x squared plus 3x. Subtract. Change all my signs. I get a 0, I get 8x squared. I get minus 2x. Bring down the minus 1. And I need an 8. So I get 8x squared plus 16x minus 8. One last subtraction step. Change all my signs. I get negative 18x plus 7. I know I'm done because the degree here is less than the degree of my divisor. So my answer, the answer to the division problem, I could say 2x squared minus 3x plus 8 plus negative 18x plus 7 over what I divided by. If you're asked straightforward to just divide, you can write your answer just like this. You don't need that beginning part necessarily. All right, next one. Put the x plus 2 out front. Put my dividend inside. And we begin our division. I have an x squared, making it x cubed plus 2x squared. I subtract, change my signs, making it a 0 minus 3x squared. Bring down the next term. Well, x times negative 3x. So I have negative 3x squared minus 6x. I subtract, so I change my signs. I get 0, I get 10x. Bring down my minus 10. I need a 10 on the end here. That makes 10x plus 20. I subtract, change all my signs. I get negative 30 for my remainder, which means the answer to this division problem is x squared minus 3x plus 10 minus 30 over x plus 2. You could put plus negative 30 over x plus 2 as well. Same thing, right? All right, so now you're going to practice just some long division. It's actually out of the textbook instead, not this worksheet.